Hi everyone. Today we are presenting the final result implementation. We are group 10, myself Ali and my teammate Jas and Joshi. Our topic is AWS security solution for financial service. So for this task, I work with Amazon S3 Glacier, which is used for storage. Then I work with Amazon RDS and Dynamo for backup and some fraud detection, and then I work with security setup for creating the admin's roles and everything. Okay, so yes, for IAM I use user roles and policy, then multi-factor authentications, and then CloudTrail for log, and CloudWatch for alarm for if the GPU is exit. So that's all from presentation. So if I go for the main task, so at first I create users in IAM. So here the user is this one, admin Ali. Here I authenticated with multi-factor authentications and all, and then I use some policies or here. So yes, and so that's all from here. And then after then I work with the storage for S3. So if I go there, I create a bucket. So this is the bucket, FS4 records Ali. So here I already uploaded sample files, and I already give all the permissions, like yes. So here I already give all the permission, like enable SS3 for encryptions, and yes, for encryption I use S3, and then I give some permission here, and back policy I use some policy here, and then I used some lifecycle roles. This one I configured. After 30 days it will move to the standard IA. Then I use DynamoDB for fraud detection. So here if I go for tables, so here this is for fraud detections. I used here some fraud detection is there. So if any fraud is here, it will comes to the here. Then I use some policy also. So yes, if I go to the policy, I configured one policy for this, like DDB. Yes, this one I configured for the fraud detections. Yes, that's all from storage. So after that I use the database for financial record and everything. So I used RDS NoSQL data. So here is the database. Usually you can see financial is already it's already encrypted, and it's already backup for backup in 7 days. So here, yes, see, it's automated backup in 7 days. And I also use this PG admin. I already connected with this, and if I go for my DB, this is my database. Actually I will show you from the very beginning. So yes, so this is statistics dashboard. Yes, this is my table which is I already connected, and sorry, this is my database which I already connected. If I go for my table, so this is public. Then if I go for tables, this is customers table I already created. So if I query like all row, it will take some time. Yes, this is my it's already successfully done, and this is my database table for my financial data and everything. So after that, okay, so after that I use CloudTrail logging. So if I go for CloudTrail for logging and everything, I already created the trails here. See, you can see here I already configured everything for logs. So if I go for event history and check the event name, like create bucket. Yes, so here it's already the log is here. And one more thing I already configured, like CloudWatch to set up a alarm. If the GPU is exceed more than 80%, it will make an alarm, like all alarms. Yes, this alarm one I already configured. So if this is GPU's exceed more than 80%, it will alarm. And if I go for matrix like RDS, I already configured this also. So yeah, this all for me. My teammate just will present the next topic. Thank you.
So I in our project, my part is a focus on the security in AWS, which protect the financial situations like cloud workloads. So AWS provides a layered security using five main services like Cloud Trail, CloudWatch, GuardDuty, RWF, and Shield Standard. These services help us detect, the monitor, and prevent cyber threats while maintaining the compliances with like PCI DSR and like that. So it's the PPT I have prepared for my presentation. This includes all the topic I have mentioned before. So I'll go to the demonstration of that my Amazon AWS because I'm demonstrating my Amazon AWS from here because my Amazon account is having some issues. So I'm recording the screenshot here. I've done it. I've done it already before submitted. So like for Amazon Cloud Trial, so there are this screenshot for this AWS Cloud Trial, which logs every activity in our AWS account. So that API calls, user actions, and other all the configuration changes. Then so I created a new trial here, named like it's already named like finance trial logs to find it's my uh, registration number. So these logs are tamper proof and help us to track unauthorized access and like suspicion activity. Okay, so finally the cloud integrates with the cloud watcher to trigger alerts when usual action occurs, for example like fade login attempts like that. So it's all based on what I told now, like how to make those trial. So when we come to this Amazon CloudWatch, so this screenshots for CloudWatch are refers that like which monitors the AWS resources. The CloudWatch monitors the AWS resources such as like EC2, S3, and RDS. So in my setup here, I created an IAM role and attached the CloudWatch agent service policy to allow the agent to collect the metrics. Then I deployed the CloudWatch agent to send system logs and configure alarms for critical thresholds like high CPU usage or like some unauthorized activity. So when the alarm is triggered, the SNS notification is sent automatically to the administrations. So these all are there. So when it comes to that Amazon Guard Duty, so it's like that here we like it analyze the cloud trials, logs and VPC flow logs and like, so I have enabled here the guard duty and configured to export finding to the S3 bucket. So using Amazon Event Bridge and SNS, these alerts can be automatically trigger a response or notify the security team. So the Amazon guard duty does that. So the next is that Amazon AWS web application firewall. So here what we done was like the WAF, which protects our web applications from attacks like SQL injection, cross-site scripting. So I created the web ACL, selected the scope from CloudFront, selecting the scope like the CloudFront and applied the AWS manager rules for SQL and the XSS protections. So WAF filters incoming HTTPS then previous traffics and blocks. So WF actually filters the incoming HTTPS the HTTPS traffic and blocks all the malicious activities like they block before that reaches to the applications. So like that. So when we come to this AWS Shield standard, so the AWS Shield standard, which provides always like on DDoS protection for CloudFront and Route 53 and like which all are free of cost, and it automatically mitigates the large scale attacks at the network layer. So I verified that our applications are like hosted behind the CloudFront and which ensure the shield is active. So any DDoS metrics can be monitored via CloudWatch. So in conclusion, so security in AWS isn't just about like preventing attacks. It's about continuous monitoring and rapid response using that CloudTrail, like how I mentioned, CloudTrail, CloudWatch, GuardDuty, WF, and Shield. So you achieve these all, and so we secure the architect using these all to for a like suitable services.
Hello, my name is Dhyanam Joshi and my part is network security. So these are all the topics that I'll be covering throughout this presentation. So let's quickly jump to the AWS console. So we started by creating a VPC named Financial App VPC. So I'll quickly explain you the whole architecture using the resource map. This is our VPC and we created 4 subnets in 2 different availability zones in 2A and 2B, and we connected both the public subnets to our public route table and we connected both our private subnets to our private route table. We provided the internet access to our public subnets using the internet gateway that we have connected to our public route table, and both the private subnets are connected to the network address translation table NAT, and our NAT is connected to our private route table. So I will quickly show you our 4 subnets. So if we select any of the private subnet and then if we see the route table, then it will have the NAT connected, and if we see any of the public subnet, then we'll see the if we see the public subnet, then we'll see the internet gateway. Then going to the route table, if you see the subnet associations, the private route table has both the private subnets and the public route table has both the public subnets. Then moving forward, this is our internet gateway that we created. Yes, this is the network ACL, which is basically stateless, which means that we need to provide inbound rules, and we also need to explicitly define the outbound rules. These are the inbound rules that we have defined, and these are the outbound rules that we have defined. And ACLs are basically, they apply on the whole subnet. They apply on all the instances of the subnet. So the subnet association with our private ACL, you can see both the private subnets over here, and for the public, we can see both the public subnets over here. Whereas on the other hand, security groups are stateful. So when you define the inbound rules, you don't need to define the outbound rules explicitly, and they apply on the full, they apply on instances, they don't apply on the full subnet. So these are our created security groups that we can see over here. We have created 2 EC2 instances, which if we see the private, we don't have the public IPv4 address for the private EC2 instance. And when we go to the security tab, you can see it is associated with SG app security group. And on the other hand, if we go to the public EC2 instance, then we have public IPv4 address. And if we go to the security tab, then it is associated with SG web, which is a different security group. So as I mentioned, security groups apply on a particular instance, not the full subnet. And we can see over here it's been associated with our VPC and to public subnet. So these were our EC2 instances, and this is our CloudWatch. Because we associated a flow log with our VPC, so we can actually see all the traffic over here with CloudWatch. And you can see there is 443, which stands for HTTPS, and we can see it has been accepted. So all the rules that we have kept in place are working properly, and we created this using curl command, and uh, we can see that it has been accepted. Then the direct connect has actually we need to complete the full account setup. For that, direct connect basically has a dedicated private fiber link, and we basically bypass the internet, and for the low latency and high reliability. And I also made VPNs over here. So first I created virtual private gateway that I associated with our financial app VPC. Then I created customer gateway, this, and then I connected both the customer gateway and our virtual private gateway using site-to-site VPN connection. You can see over here, this is our virtual private gateway and this is our customer gateway. So this way, uh, to summarize, we built a VPC with public and private subnets and connected EC2 instance and secured them using security groups and network ACLs, and monitored traffic flow with flow logs, and extended network connectivity with VPN and direct connect. So this shows us the full AWS networking implementation. Thank you.